All right. Welcome back to those of you who saw me yesterday in our Zoom call. Hello again to those of you who didn't. Hi, welcome back from spring break. Hopefully it was restful. I know you couldn't go anywhere, which is a bummer, I understand. But I hope you got some sort of mental rest from it, and that's something that can always be valued. But today, we just finished last time. I saw you talking about speed and how to calculate speed, and you saw how out of shape I am. I have not made any attempts to change that, so I should probably get on that. But today, we are talking about acceleration. Acceleration, I'm sure we've all seen this term before. You can put it in the context of a car. Your parents can use it when they're driving. Acceleration is the gradual increase of speed over time. So speeding up, trying to hit that top speed. So the definition is the gradual increase in velocity. Velocity is a term that I have not used yet, but it is important when we get to the equation for acceleration. Velocity is the exact same thing as speed. The only difference is that it takes into account the direction you're going, but we don't need to worry about that. But all we need to see is that velocity and speed are the same. So it's the gradual increase in velocity, which is speed, over time. So from this definition, we can actually gather all the parts of the equation for acceleration. So acceleration equals velocity, which is the same as speed, over time. The gradual increase of velocity over time, A equals V over T. Now, where this gets tricky is I want you to understand why the units are what they are for acceleration. Acceleration is measured in meters per second squared. And we need to look at why. So, velocity over time. So the units for velocity, just like speed, are meters per second. And they're divided by time, which we're just going to say this time is in seconds as well. So we can rearrange this, make it easier to see in this form, meters per second divided by seconds. And any whole number, like if I said, I don't know, where do I want to write this? Up here. If I said 3, that is the same as saying 3 divided by 1. So seconds is the same as, this singular s is the same as saying s over 1. And when we divide fractions, I know you've learned this before in a math class, but when we divide fractions, remember we flip one side and we then multiply. So this turns into meters per second times 1 over second. So what we end up with when we multiply this across is meters per second squared. This is just so you know that is what acceleration is measured in. Acceleration is measured in meters per second squared. I wanted you to know how we got there. All right. So looking at acceleration, gradual increase of velocity over time. If we look at a graph, all right, so we have a graph here. If I said that an object was going at 1 second, it was traveling 1 meter per second. At 2 seconds, it was at 2, 3 at 3, 4 at 4, 5 at 5, and 6 at 6. Our graph would look like this, very linear. But we could actually see the acceleration from this. So remember, acceleration is velocity over time. Velocity is the y-axis, time is the x-axis. So we'd be increasing 1, 1, 1, 1 over 1, 1 over 1, 1 over 1. Our acceleration would be 1 meter per second squared, because each of these increases is 1 meter per second over 1 second. So, looking at a graph of velocity over time, you can calculate acceleration. In your homework, I'm gonna have you graph your acceleration. So, we'll do another Zoom call tomorrow because I know that's gonna be tricky, but that is gonna be on the homework. So, it's just graphing velocity over time. Velocity on the y-axis, time on the x-axis. Its velocity is 1 meter per second at 1 second, 2 meters per second at 2 seconds, and just increases 1 meter per second squared. All right. So I'm going to give you a tangible example. I'm going to do a quick video on how to calculate acceleration in the real world. So I'll see you in that. So acceleration is velocity over time. And that's going to be hard for us to measure unless we have a known distance and a known velocity, which is hard to track. But I've gotten an app for my phone where it tracks the velocity of the phone, and I'm going to use that to calculate acceleration. So I measured out this door before I started, and it is 2.032 meters. So I know my distance, and now I'm going to track my time. I'm going to drop it from the top of the door until it hits the ground, and we'll see how long it takes that to happen, and then we'll have all the data that we need to calculate acceleration. So, bring it up here, bring it out, because I don't want it to hit the door, and 3, 2, 1. It took 0.63 seconds to fall to the ground. I'm going to look at that data, and I'm going to write it down, and I'll meet you back at the papers where we can calculate acceleration with the data we just gathered. All right, so my phone is not shattered, and I got some good data. We're gonna look at that data real quick. So my door, the distance, so my screen is not cracked, and I got some good data. So our door, remember, was 2.032 meters. So over that distance, it took our time was 0.68 seconds. From my phone, I gathered that my velocity was 6.63 meters per second. So now we need to calculate the acceleration. So acceleration, our equation, is velocity over time. So plugging this in, acceleration equals 6.63 meters per second over 0.68 seconds. Let me calculate this out. I'm going to use a calculator because I can't do that in my head. Here we are. So 6.63 divided by 0.68. We get 9.75. And our units, remember, as we talked about before I did that, are meters per second squared. So, acceleration is 9.75 meters per second squared. It's as simple as that, but I'm going to get some graph paper. I will be right back. All right, so I got my graph right here. We have velocity on the y-axis, and we have time on the x-axis. So we know our acceleration was 9.75 meters per second squared. And we have this graph. So if we know that every second is going 9.75 meters, so at time 1, it should be at 9.75. At time 2, it should be at 19.5. And at time 3, it should be at 29.25. Connect my dots. And that's my equation. That's my graph. Every second, it's going 9.75 meters per second faster. So, acceleration of 9.75 meters per second, this is what the graph would look like. So, on your homework, you're going to have to do something similar. I'll get a picture of graph paper that you can put into Notability so that you can actually make your graph. And I'll be doing a Zoom call tomorrow to help you guys out with that. So, that is it. Good luck on the homework. And the Zoom call will be at 1:00 p.m. And I'll put that in the description of the assignment as well. So, more math. Sorry about that. That's just the unit that we're in. Newton's second law is what we're going to get to on Friday. So, this will have us prepared for that. Have a good day.